Hey everybody. Today we're going to be talking about setting up our proximity distance sensor. Now, let's make this thing big. So proximity distance sensor is a digital sensor. Okay. On here we have a couple different pins that we're going to need to connect up. One of them is marked as GND or ground, and one of them is marked as VCC, which means voltage coming in. Okay. So ground is going to get connected to ground, and VCC is going to get connected to 5 volts. Then we have what's also called the trigger pin and the echo pin, and those are going to be the pins that are actually communicating back to the Arduino. Okay, so ultimately you're going to still need your speaker for this activity, or at least the second half of this activity, but honestly, like right now mine's kind of in the middle. I'm just going to like rewire it so that it is off to the side. Okay, so that's cool there. Then I'm going to start to set up my distance sensor. So, we need to basically plug our distance sensor into 4 separate rows. I'm going to plug my distance sensor in something like this. To begin with today, we're just going to be doing like a base code to just like measure distance away from this distance sensor. And then later on, we're going to be creating like a alarm system so that when something walks past this or breaks this like plane, it's going to turn your beeper on. Okay, so ultrasonic sensors work like sonar, like on ships or bats or anything else. One of these is a speaker, while the other one is actually a microphone, despite the fact that they both look very similar to one another. And what happens here is ultrasonic sound wave, right? So ultrasonic means that we can't hear it. But a really high-pitched sound wave comes out of the speaker. It bounces off of an object, like let's say a wall or your person, and then it will bounce that sound back again, and the receiver or the microphone is going to measure how long it takes for that process to happen. And it's going to convert that time into an approximate distance. Okay. So again, we're going to have this thing set up like this, and we're going to do a couple different wiring activities. So again, we're going to need our wires. We're going to need a short black one. Let's see here. Okay, so after a little bit of searching, I found a short black wire, I found a short red wire, and I found 2 other colored wires that we're going to need for this system. Okay, so again, ground connects to ground. Bingo. That's easy. 5 volts, which is the opposite side, is going to connect to 5 volts. Okay, so again, I'm just paying attention to like what these things have to say and then connecting them where they belong. Okay, now for our code today, we're going to say that the trigger pin, which is a TRIG, the trigger pin is going to connect to pin 12. So we have 8, 9, 10, 11, 12, while the echo pin, so the echo pin is like what's going to send out the sound, and then the trigger pin is going to be the thing that measures the sound. That's going to get set up to pin 11. Okay, so that's my general wiring. Again, I have this thing shoved off to the side so that I can like put my hand in it and get some different dimensions and whatever else. All right, so that's the end of the wiring. Let's move on to just some base code at this point. Okay, so like always, Mr. A. So this is going to be my distance sensor example. And here I have my distance sensor. That's really it. Like, despite the fact that I have the speaker on here, for right now we're not going to use that. So we have a distance sensor, and on that we have VCC to 5 volts. We have the echo pin on 11, and we have the trigger pin on 12. Okay, now in order to make this thing work, we actually need to use a library. Okay, so again, libraries are like groups of firmware code that are written by like the manufacturer of the object typically. Okay, so we're not going to like program this whole thing from scratch. We're going to use the library to like do a lot of the heavy lifting for us, honestly. But we need to get that library. So we can do two different things. I have included the library in Google Classroom. You can download the zipped file from Google Classroom onto your computer. Or if you know exactly where your curriculum materials are that came with our kits, it's in there too, right? So that's what I'm going to do. But either way, you need to download the zipped file, and then you're going to go through these processes, okay? So we're going to come up to Sketch, and we're going to say include library, and we're going to add a zip library, all right? So for me, I have put my curriculum and support materials on my desktop. So that's where I've gone to find them. And I'm going to go to module learning, and I am going to open up 2.9, the ultrasonic sensor module. And then inside of here, we see the library HC-SR04. Okay, that's the library that we need. And again, you can find this exact file in Google Classroom, and you can download it, and then it will be in your downloads that you're going to find this thing. Okay, so we're going to click open. And so the library has been included, so now we can check our include libraries menu to find it. All right, so we're going to go up to tools, and there's it under sketch. Yeah, sorry, sketch, include library. And now we should have the HCSR04. Okay, and actually I don't really want that up there. I want that below. Okay, so just cut and paste. Okay, so we are going to include the SR04.H. Okay, so again, that's the library for that thing. So we're also going to do something, you know, like often we will create like integers for different things, but with this, it wants us to define our pin. So in order to define a pin, you're going to do like a hashtag and then define, or a pound sign define. Then we can name our like thing. So we're going to say that the trigger pin is in space 12, no semicolon, which I understand is kind of confusing, but no semicolon there, just like there's no semicolon at the end of include. Then we're also going to define our echo pin. And again, that's in pin 11, okay? And now we're going to create like a data type. And this is a little bit confusing because most variables and data types that we're familiar with are things like integers, longs, booleans, that type of thing. But actually, as part of this library, it's created its own integer types as part of the library included in the SR04H. So we actually want to type the SR04, create that in all capitals. Notice now it's orange, right? And if I didn't have this line in here, I don't think it would be. Oh, maybe it is still. I guess it's because of the library, but SR04, we're going to say SR04, so these are lowercase. So again, this is like a name. And again, it's all case sensitive. So despite the fact that both of these say the same thing, this is capital, so that's one thing. This is lowercase, so that's a completely other thing. And that's going to be set to a capital SR04. So again, we're like pulling up that library. And then we're going to say, okay, the echo underscore pin, and then the trig pin. And we're actually going to be returning values in this, okay? So we're going to be like returning it's going to go and it's going to look at the echo pin, and it's going to determine like what value the echo pin has, and it's going to value what value the trigger pin has. So in our setup here, we're going to say, okay, serial dot begin 9600. Okay, because we're just going to print serial information. Okay, so starts serial communication. And then let's just delay like a second just to like wait a moment. No real reason for this. Wait 1 second, but just gives us some time before we get into the loop. Okay. So, oh, I forgot to, I'm sorry, super sorry. We need to create a long integer, and that thing is going to be called like, it could be really anything. It could be like a lowercase distance. It can't be capital distance because the program uses that. It could be like an X or a Y. I'm going to call it an A for right now, but this is going to be the variable that holds the distance data. Okay, so part of this thing, like when we look at this, there's actually like a pretty intense circuit board built into the back of this. Like this whole unit does most of the processing on its own. And again, that's part of the library. Like the library is telling all of these circuit chips on the back here, like what they're supposed to be doing. So there's really not that much to program here. It's really more of just like utilizing the program that's been given to us by like the software itself, at least to begin with here. So here we're going to say that A, which again is like the distance, A is equal to SR04 dot capital DIS distance. Okay, and again, distance is orange. So again, we're referencing now this thing up here. And when we call this, it's actually like calling all of this. So it's going to automatically check the trigger pin or the echo pin and the trigger pin. And it's going to feed that information into this distance subroutine. Okay, so we have the subroutine, which again, if we were to like look at the library, there would be a distance subroutine, and it's going to like feed all that information in, and it's going to spit some stuff out, right? So there's a lot of like black box stuff going on here, which is true, honestly, for a lot of programming. Like to use libraries on things is totally normal. Okay, so we're going to serial print A. Okay, which is going to be that distance. And that distance is actually measured in centimeters. So we're going to say serial print ln, and then in here we're going to say centimeter. Okay, just our cm, just so that we have a label. And then we're going to wait 1 second, and then we'll repeat the process again. Okay, so this thing is going to read the sensor and save the distance value to variable A. This is going to print variable A. It's going to print CM and then skip a line. And this is going to wait 1 second. Okay. So let's save this file, save as. We're going to save this as, what did I say this was? The distance sensor example. Save. Bingo. Okay, so from there, let's upload and give it a try. We'll see real quick here. Okay, so let's just take a quick look at the output here. All right, when there's really nothing in front of it, we're going to be reading really big numbers. And then as I go to bring something in, like let's say my calculator here. Okay, and as I slide my calculator closer to the sensor, if you can see down in my webcam in the bottom right, it's going to change the distance away. So when I go to measure between these 2 points, which is difficult for you guys to see probably, but we are roughly 11 centimeters, and this is saying 10 centimeters, so it's pretty close to being accurate, not completely, but pretty close. So the next test that we're going to be working on after you guys get this working, the first thing is we're just going to turn a tone on when the beam is broken, okay? So like when the value, when something like walks by, we're going to just have the speaker make a general noise, okay? Then after that's done, we're going to work on changing it so that the closer something gets to the sensor, the higher the pitch of the piezo speaker is. And I might suggest using a map function to make that work along with your tone, okay? So those are the 2 tasks to work on next. Let me know if you have any questions. Okay.